The saying still 2018 exam paper. Section 5 B1. Sketch the graph of the curves y is equal to x and y is equal to x squared. Hence, step 2, find the area of the region bounded by the curves. Solution. To sketch the two curves, y is equal to x and y is equal to x squared. Because they are all y's, they must be equal at some point. Implying that if we square this side and we square the other side, we're going to have x4 is equal to x. If we square the other side, we have x4 minus x is 0. And so that we have x3 minus 1 is 0. So x is 0 and x is 1. These steps will meet at those two numbers. So because they are meeting on those two numbers, when x is 0, we're now sketching root x. So root x, the nature of these graphs goes like this. And then x squared is a graph which goes like this. So they will meet at 1. And at 0. So sketch them, indicating also their intercepts. Then find the area of the region bounded by the curves. So you say the area is going to be the integral from 0 to 1 of the upper curve, because you're talking about the region inside, this region here. So we'll have the upper curve, and the upper curve is the curve root x minus the lower curve, this curve here, which is x squared, and then dx. So to integrate here, we can write this from 0 to 1 as x to the power half minus x squared dx. X to the power half, to integrate, you add the 1, it becomes 3 over 2, and divide by the same, minus x squared, you add the 1, it becomes 3, and divide by 3. Then calculate from 0 to 1. So if you substitute 1, you have 1 over 3 over 2 minus 1 over 3. You substitute 0, you get 0, 0. So this is the same as 2 over 3 minus 1 over 3, which is equal to 1 over 3. So because it's area, we are saying the area is equal to 1 over 3 units squared. So that's how you find the area. This type of questions.
Excuse me, sir.
Used.
Yeah, how did you find the behavior or the function? Like, how have you plot?
I don't understand what you mean by the behavior. X squared is a quadratic sketch. And since it's positive, it's facing up. And it is 0 when x is 0. And then root x, we call this as radical functions, which are 4 families. The domain of root x is all x greater or equal to 0. And it has that family curve. So this is y root x, and this is y x squared.
What I think.
Okay.
Professors, good evening.
Okay. Then we go to C. C, part 1, resolve resolve 1, 2x plus 1, and then x minus 2 into partial fractions. So resolve into partial fractions. Now I said that if I have linear, the partial fractions are going to be a over 2x plus 1 plus b over x minus 2. And then the first step is to multiply this whole thing by 2x plus 1 and by x minus 2. So when you do that, this piece multiplied by that piece, you get 1. And then this piece will take away that piece. So we remain with a x minus 2 plus b. This piece will take away that piece. So we'll have 2x plus 1. And then you can choose to expand. So 1 is equal to ax minus 2a plus 2bx plus b, meaning that I have a plus 2b as coefficients of x, and since there's no x on the left, then I'm equating to 0. And then I have negative 2a plus b as the constants, and since there's a constant on the left, we equate to the constant. Then simultaneously, if we multiply the top one by 2 and the down one by 1, then we're going to have 2a plus 4b is equal to 0, and negative 2a plus b is equal to 1. And then we subtract, or we do the addition. So we'll have 5b is equal to 1, telling us that b is 1 over 5. If we know B, then you can easily know A. We just pick this equation here from the first equation. Since B is 1/5, then A is -2/5. And so the partial fractions, therefore, or I can put them here, of 1/2x plus 1 multiplied by x minus 2 is equal to A is -2/5 over 2x plus 1 plus B is 1/5 over x minus 2, which is equal to -2/5 2x plus 1 plus 1/5 x minus 2. So these are the partial fractions for this. And then the next part 2, says, hence, evaluate, in fact, not the next part. It's just a hence here. Evaluate the integral of 1/2x plus 1 x minus 2 dx. So since we know that the partial fractions of this are here, then we integrate -2/5 2x plus 1 dx plus 1/5 x minus 2 dx, which is equal to, we can take -2, we can actually just take -1. We can take -1/5 and leave 2/2x plus 1 dx plus take also 1/5 and leave 1/x minus 2 dx. And for the first piece, we can let u be 2x plus 1. What will be du? Du is going to be 2 dx. So you can substitute. We have -1/5. The 2x you are seeing here is equal to du. So we have du over the 2x plus 1 is equal to u over u plus the second piece, we let u to be x minus 2, and then du is going to be 1 dx. So we have 1/5 integral of the 1 dx we are seeing there is the same as du over the u to take the place of x minus 2. So this integral here is -1/5 ln u. I can call u1 u2 to avoid conflicts, plus 1/5 ln u2, so that I don't get confused on which one to substitute back. So the new one is 2x plus 1 plus 1/5. The new 2 is x minus 2 plus a constant c. This becomes the integral of such a function. So partial fractions, in most cases, that's how they come.
Sir.
Hello.
Yes, the first one wasn't it supposed to be positive 1/5?
The first one. Wasn't A supposed to be 1/5?
Yes, I'm talking about the negative sign.
On A. So since
Yes,
we got B to be positive 1/5, and then we have the equation A plus 2B is equal to 0. If we substitute here, we put 1/5, we're going to have 2/5. So it will go the other side as a -9, the -2/5. And then check this, the position of A. First one which has a negative. I don't know if that's what you're talking about. This all together was -2/5. And then when taking out of the integral, we have only taken out -1/5. We have left the 2 inside. Okay. This was C1. And then C2. Okay, integrate 1 to root 3, 1 plus x over 1 plus x squared dx. So this is exactly the integral from 1 to root 3 of 1 over 1 plus x squared dx plus the integral from 1 to root 3 of x over x squared plus 1 dx. For the first one, if you remember very well, the derivative, when we differentiated tan inverse of x, its derivative came out to be 1 over x squared plus 1. So that the integral of 1 over x squared plus 1 is going to be tan inverse of x, evaluated from 1 to root 3, and then plus the second part, we let u to be x squared plus 1, and then differentiate it to be 2x dx. And then divide by 2, to have du over 2 is equal to x dx. So here we are having the 1 over 2 integral from 1 to 3 of du over u. So that our integral then, we haven't evaluated this one. It's coming from 1 to 3 plus 1 over 2 ln x squared plus 1 from 1 to 3. We can now substitute. So we have tan inverse of root 3 minus tan inverse of 1 plus 1 over 2 ln root 3 squared is a 3 Then you add the 1, you get 4 minus half. Then 1 squared is 1 plus 1, you get 2. Except that you can evaluate this. Tan inverse of root 3 is 60 minus tan inverse of 1 is 45. And then plus, you can write the ln as half ln 2 squared minus half ln 2, so that we get 15 plus, if we drop that 2, we have ln 2 remaining minus 1 over 2 ln 2, and so 1 minus half is half ln 2. So we can leave our solution in this form. Is it okay? All the properties of logarithm that play. Hello?
Selamat datang.
So,
Hello?
so yeah, so now if you don't want to use like tan, whereby you just say that
It's not
there,
an
you
option.
just say that
Let's do this.
It's not an option.
it's not an option.
It's not a 0.
Eh?
That's an integral of 1 over 1 plus x squared. What else can you use that? What's the integral of x? If you don't want, if you don't want to use powers,
Integral of x, sir.
if you don't want to use
It's 2x squared over 2.
now, if you don't want to use this one, what's the other integral of it?
If I don't want to use that one. No, I was saying there just for tan, maybe quick at the -1.
No. It can't. Because look, if you try to put it that way, to integrate 1 plus x squared of -1, you don't have that integral in any way. So, so you can't, unless you're able to expand this thing. Now remember that expanding this thing, it becomes a binomial series that will never end.
Yeah, recover.
And I know you like, I know you used to miss a lot of classes. That's why you're wondering, did you ever do the derivative of tan inverse? What we did? And the videos are all of what COVID is doing. Okay. Evaluate the limits. Evaluate the limits. 1, the limit as x goes to 3 of x3 minus 27 over x squared minus 9. 2, evaluate the limit as x goes to infinity. 2x squared plus 1 over 6 plus x minus 3x squared. Marks the marks. The first one, if you try to substitute 3, you know you get 0 over 0. So you work on the numerator. Since 3 is a factor of the numerator, then you can use synthetic to factorize the numerator. So you drop 1, you get 3, and you still have 3. You get 9, add, you still have 9. 27, when you add, you get 0. Then you are saying you can then write this limit as x goes to 3. The numerator now can be written as the product of its factor and the quotient. And then divide by x. That's a difference of 2 squares, so x minus 3, x plus 3. And then x minus 3 will go. Then substitute on the remaining. You have 3 squared plus 3 by 3 plus 9 over 3 plus 3. So that you get 9 plus 9 plus 9 over 6. That is 27 over 6. 3 in 27 can go 9 times. 3 in 6 can go 2 times. So that's the limit. The second one, because there's infinite, what you do is you go to the denominator and factor out its highest power, x squared. So you have 6 over x squared plus 1 over x minus 3. We are factorizing there. And then take this same x squared in the numerator. And then you have 2 plus 1 over x squared. Then you are saying that this x squared came from down, so they can cancel each other. The limit at x goes to infinity of 2 remains 2. The other one becomes 0. This becomes 0 plus 0 minus 3 to give us 2 over negative 3 as our limit. Very, very simple and easy. All right. So that part 2.
Sir, can you kindly repeat
Sir,
the previous page?
Sir, please
But
explain
after
2.
this one, I'm giving the previous board.
Yes.
All right.
Sir,
Yeah.
yes, please go through 2, Roman numeral 2.
So Roman numeral 2, it depends on how you factor out the highest degree of the denominator. And then after you factor out, you use the fact that the limit as x goes to infinity of 1 over x is 0. So you should find the limit Find the limit of this curve. After trying to go through to find this limit here, then ask. Part 3, find the derivative of f of x is equal to cos x from first principle.
Sir,
Hello?
I'm kind of asking for the previous slide.
That you're going to say that I'm done.
Thank you.
As h goes to 0, you get f of x plus h minus f of x and divide by h. That is the limit as h goes to 0 of cos x plus h minus cos x over h. This is the limit as h goes to 0 of cos x cos h minus sin x sin h minus cos x over h. But because we have cos x here and cos x here, we can factor out that cos x. We can factorize cos x from these two and remain with cos h minus 1 divided by h, and we split the other one as sin x sin h over h. Now, because we are talking about h approaching 0, x here has nothing to do with this limit, so it can be taken outside and then remain in the limit as h goes to 0 of cos h minus 1 over h minus sin x can be taken out. It has nothing to do with the limit because the limit is about h sin h over h. Not forgetting that the limit as h goes to 0 of sin h over h is 1, and the limit as h goes to 0 of cos h minus 1 over h is 0. Using these facts here, we're saying this is cos x multiplied by 0 minus sin x multiplied by 1. So our answer is negative sin x as f prime of x. That much we know. So we're just prove it. Then B, part 1, differentiate y is equal to e power x, and then x squared plus 2. Find y prime. So use product rule. Let u to be ex and then differentiate it you get the same ex. Since the derivative of the power is 1, so you have 1 times ex, which is ex. Let v to be in x squared plus 2. Differentiate v, we differentiate x squared plus 2, we get 2x. And then divide by the whole x squared plus 2. So that here, the derivative of y is going to be u prime, which is ex, multiplied by v, which is ln x squared plus 2, plus v prime, which is 2x, over x squared plus 2, multiplied by u, which is ex. So this is the derivative.
Sir, I have a question.
Uh-huh.
On the v prime, why is the 2x coming from the 2x over x squared plus 2? The x squared plus 2, yes, I know, but the 2x.
So if you are having a function in u and you want to find its derivative, you differentiate u first and then divide by the whole u. So our function u was x squared plus 2. If you differentiate x squared plus 2, you get 2x. And then divide by the whole x squared plus 2. That's where the 2x came from.
Okay, thank you.
What doing the screenshot we can do, because this thing will be cutting in a minute. So you can quickly join back.